Okay, so with this graphic I will try to explain to you how an equalizer works. We have decibels that is level with a zero level in the medium. It means that when the equalizer is here, it is not doing anything. When you move it in the upper side, you are giving more decibels, more voltage, more level to that frequency, and when you're going down, you are cutting that frequency or that voltage. And in the lower side, you have frequency. So you can see the main frequency of every graphic is always 1 kilohertz or 1000 hertz. That's why our human ears are made to listen that frequency like more clearly. And it's special because when you talk or the human voice, the main frequency that is acting there, the main frequency composition is 1 kilohertz. 1 kilohertz, and then you have like the other frequencies like harmonic and notes composition. So that has to be the main frequency, and then you have the octaves. It's supposed to be, I couldn't do this like, but it's supposed to be like in a frequency graphics, it should be algorithmic. I don't know if I say that word right, but that means that in a graphic is the same amount of space in the graphic between octaves. So between 1 and 2 kilohertz it should be the same space, and between 2 and 4 should be the same space. So that is very interesting because in this space you have 1000 frequencies, but in this same amount of space in this octave you have just 60 frequencies. Anyway, with this graphic, watching the frequency, I will explain you the kinds of equalizers. So the first one in the mixer that we watch, that we see there, was or is the low cut frequency or the high pass filter. This is a kind of filter that does even what kind of frequency is moving here. If it's a voice, for example, if a live graphic, it will be my voice lifting in this range, like 1 kilohertz, like the main, a little bit of high, and a little bit of low. So it will be moving like that. The high pass filter is a kind of filter that just cut in a certain frequency, cut everything below that. That is why it is called high pass filter, because just let pass high frequencies. So in that mixer it is fixed to a frequency of 80 hertz. It means like in 80 hertz it will cut all the frequencies down. And there are some specials with like the curve, like this line is cutting like really hard. All these frequencies will be cut, or another one will be like really soft, and really just these frequencies will be cut. This is really useful. I think this is like one of my favorite kind of equalizers, because, for example, the human voice can reach lower frequencies at 60, maybe like really low voices like in your chest and stuff like that. But that is not actually useful in speakers. When you have like a really big band, you want to leave that frequency range to the instruments that can reproduce like low frequencies. So I always use the lower cut or the high pass filter in every signal. Just the only one that I don't use it is on the kick drum and in the bass, or if you have a cajon with a microphone in the back part, or I don't know, another kind of instrument of that kind. But to every microphone I cut the lows. And other stuff like is really useful, and what I use it is because the pop sound, you wanna cut? The pop sound when you are listening in a big concert with really huge sub bass and stuff like that, and the person say a p like person, or an f like with a lot of air there, the microphone moves a lot because there is a lot of air with a p. So that sound is called pop. It's always around 120, maybe 90 hertz. So that is the P sound, the pop sound. So in this mixer is really low the cut in 80, but in mostly of them you cut on 100 or 120. Just when one button you are cutting that. So with one button you are avoiding to have that kind of problem, like the pop problem in the equalizer. That is really useful. And in the digital mixer that you are using on Wallspring, you can move the frequency of the low cut. So you can choose how low you need to cut the frequencies. And another kind of equalizer, it's called the shelving equalizer. That is a kind of equalizer that just works with one knob. That it means that it has a fixed frequency, and the analog mixer it should be like in 120 hertz, the low shelving, like here. And when I push the knob up, I mean I giving voltage. It means that since that frequency, I will give all the lower frequency will be lifted. Since this point to the back to the lowest frequency will be lifted. If I cut, I will cut since that frequency all the lows. So you can move the frequency. You can choose where you wanna cut or where you're gonna give voltage or decibels, but you can cut like a huge amount of frequency with that. And the high shelving is the same. You have like a fixed frequency that generally is between 5 or 8 kilohertz. And since that frequency, if you lift, you will lift in all the high frequencies, or you will cut in all the high frequencies. So you will be cutting like all this amount, since 5 kilohertz or 8 kilohertz, all that you will be cutting, or all that you will be adding. So this is special for, I don't know, cymbals, or when you need to fill the air on a vocal microphone. That is it. And the other kind of filter that is in that mixer, it's called like semi-parametric, because you have two parameters that you can choose. One is the frequency. You can choose the frequency. You have a range. It should be like 200 to 5 kilos. You can choose whatever of this frequency. With one knob, you are moving through here to here. You choose the frequency that you want to impact, and with the other knob, you will choose if you want to cut that frequency or you're going to give to that frequency. This is not that shape, it's like a bell shape, and it's fixed. So this usually has like a range of 1 octave, like the main frequency can be here, but will reach 1 octave here or 1 octave here. And that is all the frequencies that you are going to be using, like to push that frequency or to cut that frequency.